Hey everybody, so welcome to the complex rational expressions, our last lesson video, our homework practice video, whatever, flip lesson for this unit. Now, something about this one is based on materials that will be on your take-home exam. So more details about what this is about, the take-home exam that'll happen inside of our Zoom meeting, but please note that this is your take-home exam material, so it's very important that you take good notes and use this as a resource to help you with your take-home exam. So our goal today is we want to try to get through 2 problems. That's it. We're going to try to do 2 problems today. What these ones are is these ones are rational expressions like we did last time, but they are inside of other rational expressions. So I like to think about them. Cats on cats on cats. So rational expressions and rational expressions. So to get rid of them, what we're going to do is we're going to multiply every term by whatever denominator we're trying to get rid of. So in this example right here, I don't like that divide by x in that single term. To get rid of it, I am going to multiply all of these terms, the 1 over x, the 5, the 2, and the x, by that x, and that is able to get rid of that fraction inside of my fraction. So here's our first example. Just like in the one that we saw earlier, I need to multiply everybody by x in order to get rid of that divide by x. So times x on everybody. So I'm just going to write that in. But you know, that's not quite enough because that's going to get rid of that denominator, but it is not going to get rid of this denominator. So I need to also multiply all of my terms by x plus 1. Now you can do this in 2 separate steps, but to be honest, it's not worth the additional time and paper space. So I'm just going to do it all at once. If you really want to break this up into 2 steps, by all means, you can. But I don't want to. X plus 1. All right. So let's see what that ends up equaling. In the first term, I'm going to make that pink right here. In that spot, the 2 x's cancel each other out, which we wanted them to. That was the whole point of multiplying by that blue x, was to get rid of that denominator. So we end up with a 2 and the x plus 1. Plus, next we've got, I'm going to use light blue, we've got this stuff. So that's 1 times all of that stuff. Well, 1 times all of that stuff doesn't change anything. So it's still just an x and an x plus 1. That's all over. We're going to have that same thing happen again. So I'm just going to keep it blue. An x times an x plus 1. And then we've got this piece right there. The x plus 1s cancel each other out, which was the whole point. That's why we multiplied by the red x plus 1s, was to get rid of that denominator. So those 2 are going to cancel each other out. And we're left with a 1 times x, which is just x. Finished. Now what we want to do is we want to multiply all of those pieces together to see if we can factor anything and cancel some more stuff out. So in the numerator, well, here I'm going to do the denominator first. So we'll do x squared plus x plus x. So our denominator ends up being x squared plus 2x. In our numerator, we've got 2 times x plus 1, so that's 2x plus 2. We also have an x times an x plus 1, so that's plus x squared plus x. So our numerator, we end up with x squared plus 3x's plus 2. All right, now I'm going to switch to purple, and we're going to see, ooh, sorry, mouse. Let's see what happens if we factor all that stuff. And the denominator, I can factor out an x, so I've got an x plus 2. And in the numerator, we've got, let's see, what multiplies to be 2 and adds to be 3? Oh, 2 and 1. X plus 2 and x plus 1. Oh, cool! Look, these two cancel each other out. So we're left with an x plus 1 over x. And that is our fully simplified thing. Oh, that's so neat. However, we do need to go a-hunting. We need to go a-hunting to find out all of our restrictions on the domain. And it can be anywhere, so we really have to hunt. The two places that we really want to look through are at the very beginning, right before we canceled, and our final answer. Final answer is the easiest place to find, so I'm going to start there. In our final answer, we've got to divide by x. So, hey, x cannot be 0. That's important. So let's make sure, hey, x is not 0. That's good. If I check right here, there's that x cannot be 0 again. So, yep, we already got that. Right here, I've got an x plus 2. Well, what could make that 0? Well, negative 2. So that's another thing we have to watch out for. X cannot be negative 2. Moving back, we need to go back into our final beginning start. So right here, there was a denominator. So x plus 1. Well, what could make that thing equal to 0? Well, negative 1. For right here, that would make that thing equal to 0. Right there, there's a tiny little fraction. 0 would be bad. Oh, I've already got that on my list. I also need to look at what's going on with all of this stuff. What would make all of that equal to 0? And that's going to be a little bit more complicated, so I'm actually going to write that solving out. So I would start out at equal to 0. So this thing equals 0. Well, subtract a 1 from both sides. I get 1 over x plus 1 equals negative 1. I can flip both sides of that fraction. So I get x plus 1 equals negative 1 still. Flip negative 1, it's still negative 1. And then subtract 1 from both sides, we get negative 2. And it was already on our list too. Yuck. But we say, hey, we still got to check it. It's still right there. But nah, whatever. There is our final answer. That was half our time. So we're going to try one more. Try to do this one a little bit more double time. So once again, we want to multiply every term. And it's another one where it's just like, just like multiplying some of one of them isn't going to be enough. I have to use everything. So I'm going to show a shorthand for doing this. I need to multiply top and bottom by that 2x minus 5. And I need to multiply top and bottom by that x plus 7. This is an alternative way that some people write it. And then just understand that we're multiplying that whole numerator and that whole denominator, and then distribute it in. Yeah, you don't have to write it quite as many times, which is nice, but that's about where the benefit ends. So we'll start right here. When that thing gets multiplied by our blue and red stuff, the red piece cancels out. That x plus 7 cancels with the x plus 7 in the denominator. We still have the 3, and we still have that 2x minus 5. But the red piece canceled out. Then we have this minus 7. There, it doesn't have anybody to cancel out with, so it keeps everything. So minus 7, 2x minus 5, and x plus 7. In our denominator, once again, that blue thing cancels this time, but the red one does not. So here, I'm going to use red. So we got 6. The 2x minus 5 is canceled with the 2x minus 5. This cancels with this. And we're left with an x plus 7. And we keep the 6. This 1 gets multiplied by all of that stuff, so really it does nothing. So keep the 1. But we also keep the minus. We'll do blue. All right, now we have made ourselves a good big old mess, but at least there are no fractions inside of this fraction anymore. So, we got that going for us. Let's start foiling all these things and see if some stuff cancels out. I'm not going to take this thing to the end. It's really gross. You end up with this over this. And this is more complicated than anything I'm going to do on the take-home exam. And then this is factorable. The one thing I would like to do, because it'll factor and then nothing cancels, is identify our restrictions on the domain, because that's something that I really want you to have. So as I start a hunting, I'm going to start down here, but I can't actually solve it. It ends up being the one that you get out of this. X cannot be 11 halves. I fully worked this out in the PDF notes, and it's worth taking a look there, but it's not worth our time in our video. So this ends up getting us, it cannot be 11 halves. We check up here, we get that X cannot be -7. And if we check right here, X cannot be 5 halves. And this -7 one ends up showing up down here too. We end up also getting another X cannot be -7. It shows up there again. But yeah, that's kind of the major bits I wanted you to get out of this thing. It's not worth going through the effort of figuring all the rest of this out. It gets really gross. So it's not worth our time. What I would like you to do now is move on to your checks for understanding. This is going to be another thing like our previous video, where I'm going to be showing you some stuff and asking you to describe what I'm doing in your own words from the video. So you can kind of like pick through that video again and be like, what was going on at this point? What was going on at that point? Or why did I do this and why did I do that? Don't have to do any actual calculations. We'll be doing a couple of more of these in class together. And talking more about what that take-home exam is going to be like. Not to the oral exam yet. But that's it for today. Thanks for watching, and I'll see you in Zoom. Bye.